They just finished their experiments. They have found that it's a heat theme. Okay, now we're going. Okay, hold on. Really back. A little context between the two of them. When I say go, you're going to race to see who can get water up into that test tube faster. Ready, set, go! Okay, think about what we just learned from the candle. Ooh, I think that we might have to figure it out. Well, can you get any more? Probably not. But we've got Ethan's color in the jar. How did you do that? Ah, he pulled air out from inside the jar. Why would that work? Is it the same principle we just learned here?
Oh, there's a hole in my tube.
No, I'm sorry. I sabotaged you.
That's okay. That's right, we understand the principle.
Yeah, so what's the principle? Is it the same principle as worked here in the candle lab?
Yeah.
Is it the same principle? Okay. Really quickly for the camera because I didn't have it on. When you go around and talk to individuals in the group and you come up with terms, make sure you put them on the board. So in the individual groups, you might introduce terms, put them on the board, and then you can bring the class together and have a discussion and say, define, define, define. Then you talk about it. Okay. Yeah, so what was I having, you can sit down now. What was I having you do with this second thing? Why wasn't it, why, and why did it take you? Did it take you a minute to realize you had to pull air out of the jar?
Yes.
Why did it take you a minute? We just learned that if air is removed from the jar, because it's different, right? This is a totally different situation. So,
Same explanation, different test.
so can you see how if you learn something in one context, it often stays completely locked in that context. It's not until I make you do something else in a different context that you go, oh, wait, this applies to multiple things. Now, can you tell me how you drink a milkshake? How do you get a milkshake from the glass through a straw into your mouth? Into your stomach. How do you do that?
Create a low pressure environment.
How?
Inside your mouth. By making a close space and pulling it open, not letting air go.
Excellent. Yeah, you just change the shape of your mouth and create low pressure, and the milkshake gets pushed up into the jar, just like here. Right? Same principle. So now I've given you two opportunities to apply that in two different places. And so now you're much more likely to probably recognize it in other situations. Oh, yeah, it's the same principle. Like if you have a water jug in the fridge, right? One of those ones that has the cap and it comes out the bottom. Have you ever done, or like laundry detergent, and you do it and then eventually it stops coming out? Why does it stop coming out? What do you have to do? Yeah, you have to make so that the air pressure outside can force the water through. Same principle. So it's the same kinetic molecular theory. It's the same principle everywhere. All right, so let me outline. We're going to just totally review this. This is how we teach. We use a method called the 5E learning cycle. Okay, engage, explore, explain, elaborate, evaluate. That's what we are doing. That is the whole mechanism behind this. It's constructivist teaching, so we're trying to have you construct the information before I tell you. That's the whole idea behind get this up and then say, well, you just made all these. What are these? Instead of saying a hypothesis is a possible explanation. Let's come up with some. Let them come up with them and then say, what is this? It's a hypothesis. What's a hypothesis? Oh, well, I answered the why question. That's what a hypothesis is. That's a constructivist way of teaching when the students come up with it. And we use this format. This is just one way to do it, constructivism, and I really like it. So when they walk into lab, we engage them with something. Like the little candle at the beginning. Like the Jack the Ripper one, they come in and there's a dead body. Like, oh, take it, right? Not real, but it looks pretty real. and you engage them with some crazy story or some, and all the labs have something that's engaging. The Jack and Jill genetics, we have this boy and girl that want to get married, but she's the product of an anonymous sperm donation, and his dad was a sperm donor, and so they could be brother and sister, and so like something that's just engaging. Okay, then this is the most important part, and this is what you're doing in lab. Explore. So that is when you are, basically your job is to set up the environment for the students to build the knowledge themselves. Your job is not to impart knowledge to them. Your job is to facilitate them finding it, right? So you're going to think about this, and in each of the labs it's set up to help you do this, but you're going to think about how can I best set up this situation so that they run into the answer, right? So all the labs are set up in a way that they do it and they discover. Now, they're not going to discover the terms. They're not, because we have all kinds of funky terms for things. But they're going to discover the idea, we're going to put on the term. They're going to discover the idea, we're going to put on the term. Okay? So that is the explain. So you are actually doing both of these in lab. So you explore and you explain. So the explanation is when you're meeting with them individually in their groups and saying, well, what are you doing now? Why did you not do multiple variables at a time? Why didn't you test the baking soda and the lack of clay? And then they'll say, well, then you wouldn't know what's going on. Oh, so it's important to control an experiment? What does it mean to control an experiment? So that kind of that's all explain. And then when you come up, and you will do whole class discussions and put things on the board, that's all explain. And it all goes on the board. The elaborate is what they're going to do in their homework assignment. So that's going to, okay, now that you know this, let's apply it to several different situations, and then that's what we do in lecture. So in lecture, I will do elaborate on what they've learned in lab. So we'll try different ways of thinking of what they've learned in lab. And then we will also do some rounds of all of this, because there's some things that we introduce in lecture that aren't introduced in lab. So we'll do kind of repeated cycles of this. Actually, all of that in lecture.
Will the lab precede the lecture?
Mhm.
Oh, that's cool.
Yeah, that's why the lab precedes the lecture. So when they come view food chemistry, they've got nothing in lecture except for maybe a little bit of scientific method. They've got no chemistry, no macromolecules. You're introducing all of it. And then in lecture, we'll say, do you remember in lab when you were doing this? What did that mean? And let's try it in this situation. Let's try it in this situation. So lecture is always after lab. And I know Johnson and Adams try to follow the schedule well, but sometimes they get off a little bit. So it's not quite as structured in their class, but it is in mine.
So do you guys have the same tests?
No,
Okay.
no, because we haven't all sort of. But-
So the information is obviously somewhat or very close to the same, but they
Yeah.
might deviate in different directions.
Yeah, like I think they spend a little more time on phylogenetics and different places, and I do animal behavior, and maybe they don't. So there's a few things that are a little different, but the labs are all the same.
Yeah.
And they know what's being covered in lab because they have them, and they
Okay.
help design, so they know what's being covered in lab. Yeah. And then evaluate, obviously, you do this with the quiz the following week, and the quiz can cover both lab material and the 2 lectures that came in between. So lab, lecture can be on that quiz. And that's why we make sure that Johnson Adams at least know what the quiz says, so they make sure they cover,
Yeah.
yeah.
So that's the quiz that takes when you first get the lab,
Mhm.
and then we'll go into the problem.
And that's the evaluate. And we do unit exams, that's our other evaluate in lecture. Yeah, so that's the basics of it, but you as the lab TA have the most important job. Yeah, because in Bio 100, I do it all, and I do that part, but in Bio 130, I'm counting on my lab TAs to have done this, because if you do it the way I'm telling you to do it, the students will actually know it. If you just lecture through the stuff, they're going to come to my class and be lost. So it's important that you're doing it in a constructivist way. And there's tons of research. This is the type of research I actually do in my research lab. It's constructivist teaching pedagogies and how they work. And we know we've got tons and tons of data that it really does, they learn more. They can recall more later, they can synthesize more, they can create a problem, solve better. It's all, it's really, really effective. All right, any questions?
So how does the air heating getting hotter?
Oh, good answer. So when the air gets hotter, what happens to the molecules?
So they move faster
They
and
move
they
faster,
expand.
and they expand. All right.
So they increase pressure on the
Uh-huh.
walls of the jar.
So it actually forces water out the bottom of the jar.
Pushes
Okay.
water.
Then when the candle cools, goes out, what happens to these air molecules inside the jar? They slow down. So how does water go in?
Because it's pressure change.
Okay, so there's more pressure.
More pressure pushing
pushing
down on the
out
water.
Than in, and it pushes it down and that goes up.
So because it gets hotter, it cools off faster, allowing a greater change?
When and if you notice, if you were to put it on faster, so you were putting it on very slowly, so the pushing out of air was happening all the way till you capped it. If you do it fast, it'll actually bubble as the air expands.
So how
It's
come
actually
the
forcing
suction
out.
back in is a greater force than the pushing out?
It isn't. You just are missing the pushing out because you were putting it on so slow. If you put it on really quickly, you'll see it force bubbles out from the jar. And then
Oh,
you just
while
let
the
it
candle's burning?
Yes.
Oh, okay.
Oh,
Yeah.
so then the air
As
just
soon as you
stays-
put it on, it's fast. As soon as you put it on, it will bubble. Like, do it fast. Light it and do it fast. And you'll see it,
So the
you'll
air
hear
just
it.
stays in whenever it's hot.
The air starts expanding immediately as soon as you light that candle. Oops. Wet candle this time. So just keep lighting it. You have to dry and then light. So just hold it on there and don't burn your thumb. Probably two good candles too. You get one? Alright, so you're just gonna. See the bubbles? Yep, and that's all. That was enough to make the pressure change.
That's cool.
You just miss it, do it slow.
Okay.
Yep.
So it pushes out more air.
So that's how much air actually escaped from those bubbles when we were putting it on. Yep, that's the difference. And we've actually, when I've done this in class, you can take a jar and you can just heat the jar,
Okay.
and then you can put ice on it, and it'll go up, and the water will go up and
Yeah.
down without any candle at all. And that's the way, but usually when we come up with, oh, maybe it's a heat thing, I then tell them to prove it using no candles. And they can.
Yeah.
Yeah.
Okay.
So. And this is actually not allowed to do.
Yeah.
Oh,
It's my demo.
that's cool.
Yeah, because we do the termites instead. So, yeah. Anyway, it should be really well laid out, but like I said, if you have questions, and I'll do the tutorial videos, but if you have questions, come talk to me.
Okay.
I'm around every day but Tuesday.
Okay.
And Tuesday I'm available, you should call me.
You're just not on campus.
I work from home, I still have a 4-year-old at home, so
Okay.
Tuesdays I work from home usually. Can't wait till he gets in school. I don't feel less guilty about being here.
I'm going to toss the broken candle.
Yeah, if it's busted, toss it, otherwise we put
In
all the
this
stuff
tube?
back in here. Let's just dry things up and I'll take them back. Oh, that one, yeah, just pull the tube off. and throw it.
So where's the lecture? It's in the library, in the...
I'll get you the, it's in the theater.
That's cool.
I didn't know there was one.
Yeah,